Here we have to solve for the triangle that has the most information first and then apply that to the rest of the picture. So we really want to focus on the right triangle that is given. And we also want to make note that we have some parallel lines which allows us to determine angles, similar angles, based on some rules of parallel lines. Okay, so these two angles I've shown in red, the red dots, are the same angle. So we've been given two sides of this right triangle, so I'm going to solve for the third side using Pythagoras, and I'll call that side A. So we'll say that A squares, since it's a long side, we're going to use addition to calculate that side. So we're going to use the short side squared plus other short side squared. We end up with 100 plus 144. These two square areas add up to 244. So the length of side A is going to be the square root of 244. So I'm going to convert this to a decimal, square root 244, and we're getting about 15.62. Okay, since we're going to have to use these measurements, we're going to end up using decimal values in this case. So if we just solve for one triangle, we try to keep it in terms of exact values, but in this case we're solving for multiple sides, and we're going to have to use our calculator to calculate angles and ratios. So we're going to end up using decimals at some point anyways. So I'm going to write this length in. I'm going to write A on the other side here. So A is equal to 15.62. Okay, so I'm going to solve for this angle in here, which we'll call angle theta. We'll call this one angle theta as well. Clean that up a little bit. So we'll call this angle theta. And we know that we'll use the opposite and adjacent side. So opposite adjacent is TOA. So the tan of angle theta is 12 to 10. Okay, so we want to find the angle, so we need to use the arctan function. We use the inverse tan to go from ratio, the slope of 12 over 10, to the angle theta. So the arctan gives us an angle of, so angle theta works out to be 50.19 degrees. Okay, so we know that this is 50.19 degrees. We know that this angle in here is 50.19. We also know that this angle is complementary. So 90 minus 50.19 gives us this angle in here, which is 39.81 degrees. Okay, or about 40. This is about 50 degrees. This is about 40 degrees. Okay, so we can solve for this side x, and we're going to have to do that because with a non-right triangle, because this shape is not a 90-degree triangle, so we're going to have to generate our 90-degree triangle in here. So I'm just going to highlight that in green. And then now I can solve the length, these different lengths here. So I'm going to call that M, and I'm going to call that length N. And so I'm going to solve for N first, because that's my altitude of the triangle. Okay, the 90-degree line in the triangle. So I want to solve for that first. And that's going to be the opposite compared to, in this case here, I know the hypotenuse. Opposite hypotenuse is sine. Okay, so sine of the angle 50.19 degrees is equal to the opposite over hypotenuse, which in this case we've calculated to be 15.62. Okay, and this is going to be my opposite to hypotenuse calculation for angle 50.19 degrees. Okay, so I'm actually going to change that to, let's make that green. Oops. Just so that we can keep track of everything here. So it's 50.19 degrees is actually going to be that length. So I've got to convert that 50.19 into a ratio. So I'm going to use a sine ratio. So I'm going to end up with 0.768 to 1 is equal to my n to 15.62. I can solve for n algebraically, so I'm going to multiply both sides by 15.62, and I end up with, it looks like 11.9996, so I'm just going to round that to 12.00. Okay, so this length is 12.00. Using Pythagoras, we'll solve for m. So m squared. M is the shorter side of that right triangle, so I'm going to take the long side, which is my hypotenuse, 15.62 squared, minus the other short side, which is, or the short side, which is 12.00 squared. Okay, so when I do 15.62 squared minus 12.00 squared, I end up with 99.98, somewhere around there. It's basically 100. Okay, so if m squared is equal to 100, m is basically going to be equal to 10. Okay, so here I get a length of 10. So I've solved for the green triangle. I then need to solve for the other side of that, which is going to then be generated by this blue triangle here. And I know only one side of it, but I can work out the other angle in here, because I know these three angles add up to 180 degrees. So if I subtract 80, 180, I take away the 80, and I take away the 50.19, I'm going to be left with 49.81 degrees. Okay, so there's my right triangle. Have this side here. Let's call that side A, maybe. Okay, so I need to solve for side A. So m plus a will give me the length of x, and then I can use trig to find side y. So I'm going to find side. Let's find side y first. Actually, I'm going to find side y, and to find side y, I'm going to use this angle. So hypotenuse and opposite. Opposite hypotenuse is cosine. So I'm going to do this over here. So opposite over hypotenuse is so sine. So sine of 49.81 degrees is equal to the opposite side, which we calculated to be 12. Okay. Opposite side compared to the hypotenuse, which is the side we're looking for, which is y. Okay, so I need to convert this into a ratio. So I need to do sine of 49.81 degrees. Okay, and make sure that you're doing it in the right direction. Sine is going to give me the ratio. I have the angle, I want the ratio, so I get 0.7639, so I'm going to round that to 764. That's going to be equal to 12 over y, my length of 12 over the side length of y, which is my hypotenuse. Okay, in that blue triangle, solving for y, I'm going to just cross multiply that, so I end up with 12 over 0.764. Okay, so my length of y works out to be 15.71. So again, I've done some rounding in here, so if that's misleading a little bit in that we know that that's actually inaccurate, but it's about 15 and a half, a little bit more than 15 and a half would be my guess. Okay, so depending on your how much rounding you did, 15, if you're somewhere around 15.7, that's pretty good. Okay, so I still need to solve for x. I've got part of x. I need to find the other part of x. That means I need to solve for the length of a. And I think we found x with m with Pythagoras, so I'm going to find a using trig. So I'm going to use adjacent and opposite. Okay, so I'm going to use adjacent and opposite, TOA. Opposite, adjacent, TOA, tan. Okay, so tan of 49.81 degrees Okay, that's going to be equal to n, which is 12, compared to the adjacent side, a. Okay, so I'm going to do tan of 49.81. That gives me a value of 1.1837, so I'm going to round that to 4. I'm going to solve algebraically for a, so I'm going to cross multiply this. 1.184, so 12 divided by 1.184 gives me an a value of 10.14. And finally, solving for x, the length of x is going to be 10.14 plus 10, so we end up with 20.14 for the length of x.